You are being chased. Something is behind you. You cannot see it clearly, but you know it wants to kill you. Your legs feel heavy, the ground turns to mud, you try to scream, and nothing comes out. Then you wake up, heart pounding, sheets damp, and within minutes the terror dissolves into the absurdity of your bedroom at 3 a.m. You have had this dream, or something like it. Nearly every human being on Earth has. The being chased dream is the single most commonly reported dream across all cultures, all ages, all time periods, and for most of history, nobody could explain why. Freud said it was repressed desire. Jung said it was the collective unconscious. Your grandmother probably said it meant you were stressed. But neuroscience, modern, peer-reviewed, brain-scanning neuroscience, has a far more interesting answer. And it begins with a Finnish scientist who asked a question no one else thought to ask. What if dreams are not about the past at all? What if they are training simulations for the future? In 2000, cognitive neuroscientist Antti Revonsuo at the University of Turku published a theory that reframed the entire field. He called it the threat simulation theory of dreaming. The idea is elegant. For most of human evolutionary history, the world was dangerous. Predators, hostile tribes, natural disasters, disease. Survival depended on the ability to detect and respond to threats quickly. But practicing threat response in real life is costly. One mistake, and you are dead. So the brain evolved a simulator. Every night, during REM sleep, it generates realistic scenarios involving threats, being chased, falling, losing teeth, being attacked, social humiliation, and forces the dreamer to practice responding. The emotions are real. The physiological arousal is real. The only thing that is not real is the threat itself. Revonsuo's 2000 study, published in Behavioral and Brain Sciences, analyzed dream content from multiple large-scale datasets and found that threatening events are vastly overrepresented in dreams compared to waking life. People dream about being chased, attacked, or endangered far more often than they experience these events while awake. A 2019 study published in Human Brain Mapping by researchers at the University of Geneva took Revonsuo's theory further. They used EEG monitoring to identify the brain regions active during fear-related dreams, and found that the same regions, particularly the insula and the mid-cingulate cortex, were more efficiently activated during waking fear responses in people who had more threatening dreams. In other words, people who dreamed about threats were literally better at handling them while awake. The takeaway: your nightmares are not your enemy. They are your brain's training program, rehearsing worst-case scenarios so that your waking self is better prepared to face them. Threat simulation is only one piece of the puzzle. The second major function of dreaming, supported by decades of research, is memory consolidation. During the day, your brain encodes new information in the hippocampus, a temporary storage system. During sleep, particularly during REM and slow-wave sleep, the brain replays these memories and gradually transfers them to the neocortex for long-term storage. A landmark 2010 study by researchers at Harvard published in Current Biology demonstrated this directly. Participants were asked to navigate a complex virtual maze. Those who napped afterward and dreamed about the maze performed significantly better on the task when retested, 10 times better than those who napped without dreaming about it, and dramatically better than those who stayed awake. The dreams were not accurate replays. They were fragmented, distorted, bizarre. One participant reported dreaming about the maze with music playing from a cave. But the fact that the maze appeared in the dream at all predicted improved performance. A 2017 review in Neuroscience and Biobehavioral Reviews confirmed that REM sleep is particularly critical for consolidating emotional and procedural memories, while slow-wave sleep handles declarative facts. Your brain is running two different filing systems during the night, and dreams are the visible byproduct of that filing process. The practical insight: if you are studying for an exam or learning a new skill, the research is unambiguous. Sleep on it. Literally. The consolidation that happens during dreaming sleep is not optional. It is where learning becomes permanent. The third function of dreaming may be the most personally relevant: emotional regulation. Dr. Matthew Walker, neuroscientist at UC Berkeley and author of Why We Sleep, has argued that REM sleep functions as overnight therapy. During REM, the brain reprocesses emotionally charged memories, but it does so while norepinephrine, the brain's stress chemical, is at its lowest levels. This means the brain can revisit difficult experiences: a breakup, an argument, a trauma, in a neurochemical environment stripped of the stress response. It can process the content of the memory while dampening its emotional sting. A 2011 study by Walker's team, published in Current Biology, demonstrated this directly. Participants viewed emotionally charged images and then either slept normally or were deprived of REM sleep. Those who achieved full REM sleep showed significantly reduced amygdala reactivity, the brain's fear and emotional alarm center, when viewing the images the next day. Those deprived of REM showed no such reduction. Walker's conclusion, dreaming, is not just remembering, it is remembering while removing the pain. This has direct implications for PTSD. People with post-traumatic stress disorder often have disrupted REM sleep. They dream about their trauma, but the norepinephrine suppression fails, meaning they re-experience the full emotional intensity of the event night after night. The therapy is broken. The wound stays fresh. A 2020 study in translational psychiatry confirmed that REM sleep disruption is one of the strongest predictors of PTSD severity, and that interventions targeting REM quality, including the drug prazosin, which lowers norepinephrine during sleep, can significantly reduce nightmare frequency and PTSD symptoms. The takeaway: when people say things will look better in the morning, they are accidentally describing a neurological process. REM sleep literally recalibrates your emotional responses. Cutting your sleep short does not just make you tired, it interrupts your brain's ability to heal. No conversation about dreams is complete without addressing Sigmund Freud, who published The Interpretation of Dreams in 1899 and dominated the field for nearly a century. Freud's central claim was that dreams are the royal road to the unconscious, disguised fulfillments of repressed wishes, primarily sexual and aggressive in nature. Dream symbols, he argued, were coded messages that could be decoded by a trained analyst. Modern neuroscience has largely rejected Freud's specific framework. The activation synthesis hypothesis, proposed by J. Allen Hobson and Robert McCarley in 1977, demonstrated that dreams originate from random neural activation in the brainstem during REM sleep. The cortex, Hobson argued, then attempts to synthesize a narrative from this random noise, producing the bizarre, disjointed stories we experience as dreams. But here is where it gets interesting. Freud was wrong about the mechanism, but he was partially right about the function. A 2018 meta-analysis published in Frontiers in Psychology reviewed 44 studies on dream content and emotional processing and concluded that dreams are disproportionately populated by current emotional concerns, unresolved interpersonal conflicts, and anxiety-related themes. Dreams may not be disguised wishes, but they are clearly not random either. They reflect what matters to you emotionally, processed through the distorted lens of a sleeping brain. The practical insight: you do not need a dream dictionary. But paying attention to recurring themes in your dreams can reveal what your brain is working on emotionally. Unresolved stress, unprocessed grief, or simmering anxiety that your waking mind has papered over. In a lucid dream, the sleeper becomes aware that they are dreaming, and in some cases, can control the dream's content. For decades, this was dismissed as pseudoscience. Then, in 1975, researcher Keith Hearn at the University of Hull instructed a lucid dreamer to signal from within a dream by making pre-agreed eye movements. The EEG confirmed the subject was in REM sleep. The eye movements were clearly visible on the recording. Lucid dreaming was real, and it opened a window into consciousness that neuroscience is still exploring. A 2012 study published in Sleep, led by researchers at the Max Planck Institute, used fMRI to compare brain activity during lucid versus non-lucid REM sleep. They found that lucid dreaming involves increased activation of the dorsolateral prefrontal cortex, the region associated with self-awareness, working memory, and executive function. In normal dreaming, this region is suppressed. In lucid dreaming, it reactivates. Essentially, the you that evaluates reality wakes up. Essentially, the you that evaluates reality wakes up inside the dream. A 2019 study in Consciousness and Cognition found that lucid dreaming frequency correlated with higher metacognitive ability, the capacity to think about your own thinking. People who lucid dream regularly scored higher on tests of self-reflection and cognitive flexibility. The practical insight: lucid dreaming is trainable. Techniques like reality testing, habitually asking yourself, "Am I dreaming?" throughout the day, and MILD, mnemonic induction of lucid dreams, have been shown in controlled studies to increase lucid dream frequency. It is not magic, it is metacognition applied to sleep. Before we close, let us address the dreams everyone asks about, the common ones, from a neuroscience perspective, not a dream dictionary. Falling, the most common dream among children, declining with age. Likely related to the hypnic jerk, an involuntary muscle spasm during the transition to sleep. The brainstem misinterprets the relaxation of muscles as a loss of balance, and the cortex generates a falling narrative to explain the sensation. Teeth falling out, experienced by nearly 40% of adults at some point. A 2018 study in Frontiers in Psychology found no support for Freudian interpretations, anxiety about castration, or loss of control. Instead, the researchers proposed it correlates with dental irritation during sleep, teeth grinding, jaw clenching, that the dreaming brain incorporates into the narrative. Being naked in public likely related to social evaluation anxiety. A 2021 study in dreaming found that these dreams are more frequent during periods of heightened social stress, new jobs, public presentations, status transitions, and reflect the brain's threat simulation of social vulnerability. Being unable to run or scream, during REM sleep, the body is in a state of atonia. Voluntary muscles are paralyzed to prevent you from acting out dreams. The dreaming brain sometimes incorporates this real physical paralysis into the dream narrative, producing the sensation of helplessness. The takeaway: your strange dreams are not prophecies or symbols. They are your brain doing its job, integrating sensory input, rehearsing threats, processing emotions, and consolidating memories. The strangeness is a feature, not a bug. You will spend approximately 6 years of your life dreaming. 25,000 nights, 100,000 dreams. They are not noise, they are not nonsense, they are your brain's nightly maintenance, repairing, rehearsing, remembering, and releasing. And the next time you wake from a dream so vivid it lingers through breakfast, do not dismiss it. Your sleeping brain was trying to tell your waking self something important. That is the human code, running not just while you are awake, but all through the night,